Right, now we're getting into applying the formula. There are no numbers which multiply to make -2 and add to make 5, so this is going to be a formula job. You write down your A, your B, and your C, -2, and so you've got your B squared is 25, your 4AC is, A times C is -2, times 4 is -8, so B squared minus 4AC is 25, take away -8, which means you add them. And so B squared minus 4AC is going to end up being 25 taken -8 is 33. So x equals negative b. Now b is 5, so negative b is -5, plus or minus the square root of b squared minus 4ac, all over 2a, not just the end bit. 2a is 2. So you get -5 plus or minus square root of 33 over 2, which, if I remember right, gives you approximately -5.37 or 0.37, something along those lines. For the second one, made slightly more difficult by the fact that this is not yet equal to 0, so we need to add 5x to both sides and take away 8. Now we can apply the same principle. A equals 3, b equals 5, c equals -8, b squared equals 25. AC is -24, so 4AC equals -96, which means b squared minus 4AC is 25. Take away -96, which is 121. Let's take away -96 and you add them. So we get x equals negative b minus 5 again, plus or minus the square root of 121, all over 2a. But 121, when you square root it, is 11. This is -5 plus or minus 11 over 6. And -5 minus 11 is -16, and -5 plus 11 is 6. -16 over 6 is -2 2/3, and 6 over 6 is 1. So those are our answers. Incidentally, this isn't relevant to answering this particular question, but is going to be important later. If you get a number which, when you square root it, gives you an integer, that means that the original equation is factorizable. If you get a number like root 33, which is whatever it was, 5.37 or something, 5.78, can't remember. Anyway, if you get a number which doesn't square root to give you a whole number, then you're not going to have a factorizable equation. But this one, 121, you square it, you get 11. We get nice clean 2 2/3 or 1. Now, remember from the first question how, like, if you have x plus 5, x minus 3, then the solutions are -5 and 3. Well, it follows the same logic that if the solutions are -5 or 2, the factors will be +5 and +2, right? The factors and the solutions are just have the opposite sign. So factor is +5, solution is -5. Factor is -3, root is 3. What this means is that if the root is 1, that means the factor would have been x minus 1. And if the root is -2 2/3, the root would have been x plus 2 2/3. Now, how do you turn a fraction into a whole number when it comes to these? Well, if we multiply this up by 3, so we get 3x plus 8, the value of x which makes that 0 is still the same. It's still -2 2/3, because if 3x plus 8 equals 0, that's exactly the same as if x plus 2 2/3 equals 0. That's the slightly confusing bit at this stage. But if you multiply out 3x plus 8 times x plus 1, you will find that equals this. Let's take a look at these contextualized questions. This is a case of Pythagoras, so that squared plus that squared equals that squared. 7 squared is obviously 49 plus x minus 1 squared. We did this in class. X minus 1 times x minus 1, you can do it by box method if you want. X minus 1 gives you x squared minus x plus 1. It's x squared minus 2x plus 1. And that's equal to this. Why is it equal to that? That squared plus that squared plus that equals that squared. It's off the page. So now, we've got some tidying up to do because we need to make this whole thing equal to 0. So let's tidy up this side first of all. Cross this out. We get x squared minus 2x plus 49 plus 1, so plus 50 equals x squared. Now you've got x squareds on both sides. You subtract x squareds from both sides, you get minus 2x plus 50 equals 0. add 2x, and so x comes out as 25. There's only one answer. How did that happen? It's because not the whole thing wasn't quadratic. This 49 made it happen. So 25 equals x. One answer only. And you can just check to see that that works. You know, are there any negative lengths that come out of this? Well, no. That x minus 1 is 24. So that's all fine. And similarly, here's another contextualized question. What I mean by that is a wordy question. The length, sorry about the shadow, it's the camera. The length of a rectangle is 3 centimeters longer than the width. So if we call the width x, the length is 3 centimeters longer, so it's going to be x plus 3, and the area is 20. So that times that, which is how we get the area, equals 20. Multiply out the brackets, make it equal to 0, and then does this factorize? No, it doesn't. So we can apply the formula. A is 1, B is 3, C is minus 20, B squared is 9, AC is minus 20, so 4AC is minus 80, and B squared minus 4AC is 89. Oh, sorry, I've gone off the page again. So we get x equals negative B plus or minus D squared B squared minus 4AC all over 2A, and that comes out as whatever it comes out as. You're going to get a negative answer here because minus 3 minus 3, 89 is going to come out as negative. So when you do get your two answers, you're going to discount the negative one. Let me just roughly work out what that's going to be. This is like minus 6.2 or blah, 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 blah. Sorry.